One of the biggest topics, if not the biggest topic in calculus, is the instantaneous rate of change, which we're going to call a derivative later. And the instantaneous rate of change is what you see here, this tangent line. So if you have a curve, the slope is always changing, and we can find the change at that particular point by using the tangent line, or by finding the derivative of that instantaneous rate of change, which would end up giving you the tangent line, the slope of the tangent line. But what we're going to do with this to start off is we're going to talk about the slope of the secant line, which is otherwise known as the average rate of change over an interval. So from A to B, the average rate of change would be the slope between the two endpoints. That would give us the average, but not the instantaneous rate of change. If you think about average rate of change, I'm thinking about driving in a car. If you drive from here till Centro, you might go 65 most of the time, but your average speed might be 50 because you had some stops and things. Now, your instantaneous rate of change is always changing. At some point, you might go up to 75, come back down to 50, all the way down to 0 to stop. So the instantaneous rate is always changing, but your average is just that average of what was your average speed over that entire interval. It's just going to be the slope between the two endpoints. So how do we evaluate that? It's actually quite simple, and there's technically a formula for it. So if your interval is from A to B, then the average rate of change is f of B minus f of A over B minus A. And if you notice something here, this looks really familiar to another formula we use. And rate of change, isn't that called the slope? Another name for it, slope in math. And yes, this is called the difference quotient, which we use for our slope formula, y2 minus y1 over x2 minus x1. And isn't it that f of B, f represents the y, the output. So this is really just y2, because the y value at this x value, minus y1, because that's the y value at this x value. Same thing here. y2 is the y value at this x value, x2, and y1 is the y value at the value x1. So it's the exact same formula to what we've been using before. So we're not really adding anything different. And what I'm going to actually do is stick to this formula because we already know how to use it. But do recognize it could be stated this way as well. So what are our two x values, or two endpoints, or 1 and 4? So I have one point is 1, and the other one is 4. Those are x values. And sometimes they put it in an interval notation like this, or they might say like this on the interval. But this is one where they're saying, what's the slope of that secant line through the graph here? It's another way of saying average rate of change. So what we're going to do is find the outputs, the y values. So h of 1, 16 minus 1 squared is 15. And then h of 4, 16 minus 4 squared, which is 0. So now I'm just going to go ahead and do the slope formula with that. So our slope of our secant line is going to be y2 minus y1 over x2 minus x1, which is negative 15 over 3, giving me negative 5. So you could run through the f of b minus f of a, but I just did that right here. Here's f of a, here's f of b, and you just end up subtracting them anyway. So it's all the same thing. Just sometimes this is a little friendlier to find the slope between 2 points because we've done it before. This problem really similar. Let's do one with the fraction just because sometimes that's a little bit scary. So same idea. This is that interval notation I was telling you about. So these are x values. This is basically telling us what's the average rate of change on the interval from 5 to 8. So our graph is doing something on the interval, and we want to find that average rate of change from 5 to 8. So these are the x values that they're giving you. So x is 5 and x is 8. So plug a 5 in here. 1 over 10 minus 5 is 1 over 5. And then plug the 8 in here. 1 over 10 minus 8 is 1 over 2. Now it's just y2 minus y1 over x2 minus x1. And with calculus or pre-calculus, depending on the class you're on, you shouldn't be afraid of a couple little fractions. So we need a common denominator. I'll multiply this one by 5 and this one by 2. So I'll get 5 over 10, same thing as 1/2, minus 2 over 10, same thing as 1/5. Over 8 minus 5 is 3. So that gives me 3 over 10 all over 3. And technically that's a 3 over 1, right? Because we have a fraction over a fraction. So what I'm going to do is take this bottom fraction, flip it, multiply. So 3 over 10 times 1 over 3 is 1 over 10. And let me just move that a little bit. Well, actually, that's it for this video.